Hi everyone. Now we're going to look at how to do adding and subtracting of numbers that are written in scientific notation. So there's always different ways to do this. I'm going to show you a way to do this by using what we're good at. We're good at adding numbers in standard form, so why don't we just get it into standard form, add them, and then convert back. So looking at these two numbers, it'd be good to know which one's bigger, just to kind of have that number in mind, to keep that in mind. So if you look at the powers of 10, that always tells you which one's bigger, because these numbers will always be less than 10. So if it's times more tens, it'll always be a bigger number. Even if it's like 1.2 times 10 to the fifth, that's bigger than 9.873 times 10 to the fourth, because this has more tens, and that's obviously less than 10. So this is more powerful than 10 to the fourth. So not super important to do adding here, but it's good just to kind of keep in mind which number is going to be bigger. So 6.9 times 10 to the fifth, that would be, if I take this decimal and move it to the right 5 times. I want to make this number bigger because it's got a positive power of 10. So 1, 2, 3, 4, 5. I just kind of guessed right there with the zeros. This would be 690,000 for the first one. And for the second one, it's 7.2 times 10 to the 6. So we're going to move the decimal 6 to the right. I'm going to add a whole bunch of zeros on here. And we're going to move that decimal 6 times. So 1, 2, 3, 4, 5, 6. Didn't need those. So this number would be, looks like it's 7.2 million. Now we're going to add these numbers together. When you do this, you got to make sure you always line it up to the right. So this number here, I've got to make sure when I add it, I don't put it here, because that's not going to be, first off, lined up at all. I've got to line it up to the right-hand side like that. Always, always for adding. You're lining up your decimals, essentially. Even though they're not written, that's what the decimals would be. Now we just add, and then we can convert this back to scientific. Take the decimal here, move it in 1, 2, 3, 4, 5, 6 times to get between 1 and 10. And we get 7.89 times 10 to the 6. And that's our answer. Now for subtracting, it's a little bit trickier, but same idea. Let's first convert to standard form. So 1.1 times 10 to the negative 2 here is going to make a very small number. So we're going to go to the left with this decimal in order to make it smaller. So 1, 2, decimal would be right there, so 0.011. 9.6 times 10 to the negative 3, same idea. We're going to make it smaller. So we're going to go to the left 1, 2, 3 times. So that'll be 0.0096. Again, it'd be good to know which one's bigger. Kind of skip that part. So the bigger exponent is bigger. The whole number is bigger. So even though it's a negative, negative 2 is bigger than negative 3. So this number is actually bigger than that one is, which should kind of make sense once we line these up. So let's line these up. So 0.011 subtracting 0.0096. So you'll see here, we're kind of got a blank here. Let's fill in with a 0 placeholder. And now you'll see why it's bigger. The first number was bigger. So now we're going to subtract. So we're going to do a little subtraction here. We can't do 0 minus 6, so let's borrow. 10 minus 6 is 4. 0 minus 9 we can't do. Let's borrow again. And we get that. And then 0, 0, decimal 0. There's our answer. Let's make it back into scientific. Move it 1, 2, 3 times to get between 1 and 10. So 1.4 times 10 to the third. Wrong. It is a small number. So small numbers have negative exponents. So it's got to be times 10 to the negative third, not positive third. That would be a very, very big number like we saw up above. This is a very, very small number, so it's got to be a negative exponent. So that would be our answer, 1.4 times 10 to the negative